All right, and we will get started. Well, thank you everyone for coming to this presentation. I'm Sarah Kravitz and I'm the chair of the Boston BEC. Before we get started, I have a couple of housekeeping items. First, if you have any questions during the presentation, please type them in the chat and we can circle around and answer them at the end. Also, if you would like to receive AIA credits, you can click the link in the chat that I'll periodically be sending throughout the presentation as new members join in. And for a few general announcements, I also invite you to join our LinkedIn page for any upcoming updates about our presentations. Sorry, I'm going to move my cat. And I also invite you to our presentation next January by Len Tassi. He's presenting about case studies. It's called 3 Failures and a Save. So without further ado, I would like to welcome our presenter, Adam. Excuse me, Adam. Adam
Yulutsa.
Thank you.
Got it.
From someone who also has a very hard name to pronounce. So Adam has over 14 years of engineering experience, focusing on building envelope consulting, and he's worked on projects throughout the United States, focusing on the North America climate zone region in both the residential and commercial construction. He's also a part of many industry groups, including ABBA, Passive House Institute of the US, and the Boston Envelope Commissioning. And he's also put together many news articles and technical papers. So thank you for presenting today and sharing your expertise. And without that, I give you the floor.
Awesome. Thank you. Appreciate the opportunity to present. So today we're going to focus on Storefront mainly. So I passed along, I don't know if you were able to share, Sarah, there's an article that is a good resource. There's a couple resources at the end I'm going to share with the group, but there's one specifically on Storefront that I think is a good read and as a supplement to this presentation. But when we get to the end, I'll make sure everyone sees that. So we get to, oh, there we go. So yeah, just to reiterate, I'm also part of the, I'm a ABAA board member, so I know that that's the birth of the air barrier is close to your heart up there. So especially with the WAGNI Agnes conference that was recently held, which is great. But in that group, we within ABBA, I'm also on a task chair for the terminations, transitions, and flashings group, where we're trying to develop more literature for contractors, architects, consultants, anybody to reference really, but to talk about transitions. So at the end, I'll show you some papers, a paper that we published recently on curtain wall. And currently, as of today, I was finishing up some details on wall to roof transitions. So hopefully we'll be able to publish that as a resource for everybody in the industry. So I'll make sure to show you them at the end, but we'll jump right in. So I meant to change that to Storefront Glazing Assembly Edition, but we'll talk about some other systems as well, just to get familiar with commercial glazing systems. But in general, the principles apply. Storefront generally is a little bit more difficult to detail, and that's why I focused on it. Commercial windows provide a similar challenge, but we'll mainly focus on Storefront, but the principles will definitely apply to windows. Curtain wall generally is a little bit easier to deal with, but without further ado, we'll keep going. So just quick learning objectives. I always think it's good to talk about some building science principles to start it off. We'll get into the laboratory certification and testing, and then field testing of Storefront. I think that provides a lot of information as to how the system actually works. And then we'll talk about constructability, construction sequencing, and performance for the interface with Storefront. And then I've got a couple case studies, some projects that show how the interface, when it's detailed properly, works the way we want it. So just a general overview of a wall assembly. I always like to look at this. I have a bridge background, but this to me helps sort out what we need the enclosure to do. So just separating the loads. So for, just looking at it from a bridge background, we had free body diagrams. This is sort of a similar concept, but with moisture load or just general loading on the enclosure. So separating what the exterior loads are, then determining what the interior loads are, really helps you design what those control layers need to do from an air control, water control, vapor control, and thermal control standpoint. So if you have a high interior relative humidity, you're certainly going to design your building differently than if you had a low relative humidity. So understanding what each of those loads are really impacts how you design it. If you have a high exterior moisture load, you're probably going to definitely going to want a rain screen cladding that vents properly, just to make sure you're shedding water properly and that system's being able to dry out quickly. So that kind of feeds into what we're trying to do with the interface. We want to make sure that the control layers, that when we look at it in this diagram, we want to make sure that control stays continuous when we get to any type of opening or transition to another part of the building. I'm sure this group's familiar with this sort of diagram, really just outlining the control layers. We want them to be continuous. People call it the pen test. Just tracing that detail. This happens to be a curtain wall system, but for just the sake of argument or discussion, our control layers are individually shown there and continuous through the assembly. Air and water always should be continuous. You can get away with some lapping with water control, but generally you want to keep your air and water control continuous. Vapor similar. You don't always need to have that continuous to really be functional from a vapor diffusion standpoint. And then thermal control, that's the last. That's really the last frontier when it comes to enclosure. That's the last big challenge to get through, and we're coming up with great concepts to deal with that as far as thermal bridging of structural connections and cladding and all that. So, but anyway, that's certainly a critical part of a great interface. I think air and water is the most critical part to tie in. If we can get thermal control continuous up to the opening and we line up, the thermal control of the system through thermal breaks, so that we're not negating or impacting the performance of those thermal break systems, that's great. So that's just that comes second, but definitely very important. Past this. So here's a little detail. I think it's great to visualize when looking at building enclosure design. I know I get on a lot of design meetings where we just drill down on vapor diffusion, and it means nothing if you don't have air control. So that air control is typically lost at openings, and we want to make sure that the interfaces around this building are really locked in. If we spend 5 hours on vapor diffusion, but the air barrier never meets the primary seal of the storefront system, you can forget about having vapor diffusion control, because we're going to let all the moist air in or out of the building right around that great layer that we put in. So having continuous air control is definitely key to the building performing, and even to have the vapor control portion of the wall perform properly. So just jumping in now to interfacing, I like to include this nailing flange window because it makes interfacing so much easier to understand. When you have a nailing flange, you have this great flange that you can lap onto with a membrane, and that really ties in your primary air and water control layer of the wall directly into the primary line of air and water tightness of that window system. So in principle, you're you're locked in, you're good. You have a continuous transition and we're good to go from an air and water standpoint. I like to take that concept and try to think of it in commercial setting. With Storefront, you don't have that nice little nailing flange that you can lap a membrane onto. So we either have to do it with a perimeter joint, or now it's not as common, but it's starting to become more common. A silicone sheet can be used to lap onto the outer edge of the Storefront system. It's starting to gain some traction, but typically a perimeter joint is the common practice for sealing the Storefront system at the opening. Now, getting the air and water barrier out to that condition is the challenge. Whether you're doing it with blocking or some type of collar flashing, that's where the challenge comes in. And then how does that all marry together with the cladding that wants to come in the same space? So it definitely is difficult, and we'll get into some solutions later on. Curtain wall, I think we can breeze through this, but curtain wall is great in that, you have the ability, especially with pressure wall. Not all curtain walls is exactly like this, but the difference between the two here is that with curtain wall, you really get the opportunity to put two seals in. You have your outer bulk water seal, and then your primary can actually be set back. Well, that little change in the system design provides you so much more flexibility when it comes to interfacing, because you have that 2-inch of return, we'll call it, at around the perimeter, that allows you to tie into the backup wall. And then you've got this space in front of it that can seal to the cladding, and it's not all bunched up. The primary seal doesn't have to do multiple rolls. It doesn't have to be the bulk water, the aesthetic seal, and also the primary seal that keeps air and water out of the building. It can be a separate bulk water seal that just seals the cladding and looks nice. So that's the big difference between curtain wall and Storefront. Your Storefront, your primary is at the front, and you really got to make it dead on to seal to the air barrier, the framing, and to the cladding all at the same time if you're using one joint. There's other methods of how to do that, but just more difficult, and a lot of, as far as tolerances on the job, it's just more critical that things are being put together and sequenced right to get it to go right. Curtain wall is just a little easier to deal with. So I think it's important just to understand, performance criteria for these systems. When we see a product data sheet in a spec, or product performance in a spec, and then we see a product data sheet, understanding where that data comes from. I think everybody probably on this call has a good idea where the air barrier information comes from. We're running 283. Oh, sorry, this is got my slide screwed up here. So this is the performance criteria for we will call a glazing system. So typically your system's being tested in the laboratory at 6.24 pounds per square foot, and you're allowed 0.06 CFM per square foot. And then, the water performance can vary depending on what Storefront system you use, but generally you're at 8 to 15 pounds at performance. But that's what we're asking for in the lab. And I want you to see, I think it's critical to see how we're testing it, and then how that translates to the field. So similarly, we've got for air barriers, ASTM E2357. So this is an assembly test. So the key part that I want to sort of point out is that even in the assembly test, we've got this generic, we're covering, penetrations, cladding attachment in that assembly test, but that window opening detail is really generic, and we're not tackling that interface, which is understandable. We're trying to test the air barrier assembly and not test every single window type and glazing type that's out there in the market. But it's just key to understand that just because you have an assembly that met ASTM E2357 and you have a window assembly that met to ASTM E283 for air tightness and the water and water penetration, doesn't mean if it's going to work at the opening if they're not connected right. So these assemblies are tested in a lab separately. When you get on a job, they may not be married together to perform properly. So key to understand, just because you have the right materials, that's the first step, putting them together right and designing them to go together right. and then installing them in that manner is the next step and critical. So for Storefront, this is just a cut of the head condition, the jam condition. I've noted the red as the primary. So that's the outer seal. So this is actually something that in our industry is, it has differing opinions. If you look at air barrier standard details, they only detail to the interior joint. But the key thing to understand is the air barrier manufacturers they're not experts in glazing systems. The key thing that you have to remember, they're thinking of just air tightness. So they're saying, okay, the interior joint can control air, will be airtight if we tie the air barrier into the interior joint. The problem is that this system really can't handle water inboard of that outer joint. So if you're relying on cladding, flashing, or some other trade to keep water out of the head of that storefront system, there's a good chance that something's going to go wrong, or something's going to go wrong over time, because water, once it gets into the head, it really can't, it's not designed to be directed and drained out of that system. Here's why. Well, one, on your left, you've just got a cavity that water would collect in. But the other important part to see is that on that right detail, this is what you would see looking down the jam condition. So the glass is exposed at the top. We've just got basically a hollow tube that water can go right down in. So if you've got unsealed metal to metal joints, which is common interior of the glass, water can go through them. If water is laying on the glass, you could have failed IGUs. If you look at any insulated glass manufacturer's warranty data, if there's standing water anywhere near their system, all of a sudden their warranty is void. So key thing to understand, you got to keep, water needs to stay off of that system. It needs to drain and dry. We can't have prolonged exposure to IGU, water exposure, excuse me. So here's an example of that air and water testing of a storefront system in the lab. And the one thing I want you to note is that the buck that is put in there is basically air and water tight. So any water that could get onto the sides or around that system, it wouldn't be able to get inboard of that red primary joint. So what the test is assuming is that your opening condition is air and water tight. So if we want to assume the same type of performance, we want to make sure our opening on the job site is air and water tight. All the way back, it picks up the outer primary joint and the interior secondary joint. I've noted here, this is another big part to understand from an air leakage standpoint. When we do air leakage testing, both in the lab and the field, we use what's called a tear bag. And that tear bag basically isolates the storefront system from the perimeter. So even if we've tried to make the buck watertight, we sealed it with sealants, and there's always extraneous air leakage that could occur that we don't want to group into the storefront system's performance. So that's why we use a tear bag. So that's identified in green here on the right in the detail. And then you can see it right next to it in the picture on the left. The plastic is what's known as a tear bag. So that tear bag basically is airtight. We seal it to the perimeter condition. We take a measurement with the tear bag on, a measurement with the tear bag off. The difference is actually what's going through the storefront system. But the one thing I want to point out is that, again, we're relying we're basically taking the perimeter buck out of the equation. So we're essentially assuming that that's an air and water tight condition by only tearing the front face of the storefront system. Now going back to the air barrier detail, we're really not, everybody's depending on the other trade to make sure that the condition is correct. So if you're only tying in to the air barrier to the inner joint, that's going to leave that open back frame storefront system open to a drainage cavity in a rain screen type condition, or a veneer brick, or any type of metal panel rain screen system, that storefront is actually offset and it's exposed to the drainage cavity where vented air can get to that in and around the thermal breaks. And it's basically that frame is exposed to the drainage cavity, which is not good. And it's not accounted for in any of the testing that we're doing, because in the lab, again, we're assuming the buck's air and watertight. In the field, you can never get your tear bag back to the inner joint that the air barrier manufacturer is saying is the airline. So that means if we're just testing the front face, we don't know how much air is actually leaking through the system framing joints that's coming through the rain screen cavity or the brick veneer cavity. I wish we had, I don't know if we've got any questions there. I know that that's sometimes confusing to explain in words versus being in person, be able to talk through it. But there, I'm pointing at the buck that's air and water tight. There's the plane of air and water tightness. So by saying the tear bag is going to seal to that outer joint, to me, that's saying that's where we need to tie it into the air water barrier, because that's where we're measuring this performance at. So to expect to get the same performance that we're getting in the laboratory in the field, we got to make sure that that perimeter condition is air and water tight that we're sealing to, because that's really how the system was tested in the lab. So here's an example. So this is what I mean by the storefront being offset from the air water barrier. And this is a common detail that happens on a lot of projects. There's our plane of air and water tightness for the wall. So that's in green. And there's our plane of air and water tightness for the storefront. So we've got this breach. It's really, from a water control standpoint, we're relying on the through wall flashing or cladding flashing to keep water out of that head of that window. From an air control standpoint, you may, if the frame is sealed, they butter the ends and they butt the horizontal to the vertical, you might be able to get the system to be airtight, but you're allowing air, uncontrolled air, unconditioned air, better way to describe it, from the cavity to get in and around the thermal breaks of that system. So you're allowing cold air or warm air in the winter or summer, excuse me, to get around the thermal break. And basically the performance of that thermally is degraded because you're allowing the unconditioned air to get around it. So this could result in condensation in the wintertime. In the summer, it would be more just, comfort issue or just energy loss. You're allowing that warm air to get around the thermal break and basically negate even having the thermal break in there. So making sure that that system is closed off from the rain screen cladding is very critical, both from a water and air standpoint. So here's that system, in that same offset. This is what it looks like. This is looking down basically into that jam condition, looking into the head condition. It's basically a trough that can hold water. That if you look down into the jam there, you can basically, if I had a light shining on it, you would see the IGU in there. So that just gives you a real life example. This was a mock-up that we came out to see on one of our projects, and we saw that offset. We warned them of that offset being, exposing the storefront to the cavity. We ended up using a collar flashing to help them fix that condition. But before that, they were just going to leave the frame as is, and you just warn them of those issues that you could have performance wise. So thermal performance, I touched on this. This is really what we're getting at when it comes to interfacing too. I mean, the way we calculate U value and condensation resistance in the lab really heavily rely on air tightness, and I'll explain why. So when we're specifying a U value or condensation resistance factor, we're assuming when we get that product data sheet that we're going to get that. But there's things you have to understand that will go into that number so to make sure that you understand how to interface it in the field to get that same performance or similar performance. You could argue that you might not ever get the performance that you're getting in the lab in the field due to the perimeter condition, at least for now. We've got limitations on how that perimeter has to be constructed, whether it's out of a stainless steel angle that goes around or wood blocking. They're all somewhat, they're conductors of heat. So you do have heat loss there that in the laboratory, we're really not testing in that fashion. And I'll show you why. So here's just a example of therm. So I kind of went, this slide's sort of, I'd like to jump to this one and then go back, but well, no, this is correct. So when we're getting the U value, I had myself backwards there. When we're getting the U value and condensation resistance factors, when we're trying to go for NFRC certification that gets us those values, we start off with the therm model. Well, the one important thing to understand about therm is it doesn't really calculate or understand how to do three-dimensional flow, especially from a drainage cavity. It just can't capture that. Similar with WUFI, it has difficulty understanding three-dimensional airflow within a detail. It can do, you know, it's really a two-dimensional type analysis, and air is a component that we may have to make the assumption that it's not a factor. So that means that we have to make the details, make sure it's not a factor. So the therm, once we run the therm model, this actually has to get backed up with a actual test using a guarded hot box. So basically that validates the data that we're collecting in the therm model. And in this laboratory test, I'll zoom in close, but we completely take out air leakage as a factor. So all the joints, everything is sealed, because if we allow any type of uncontrolled air through that system, the data becomes too difficult to track and it's not reliable. It spikes and different things happen where the data is actually not it's not accurate, or it varies. So that just speaks to why air control is so critical. But when we zoom in, on the left is a perimeter condition around the storefront. So as you can see, behind that duct tape is actually XPS foam shoved right up to the frame. And then duct tape is placed over it to seal the perimeter. So no air leakage, and we've got continuous insulation right up to the frame. And then on the right, we don't even have, in this condition, this is storefront, we don't even have the subsill in there. And all the storefront framing joints are actually taped to get that U value. So just things to keep in mind, how much that air can impact when it's not controlled. There's certain things that we can control in the field, the perimeter condition and how it's sealed, the joints in the framing. You know, when we see gaps between the horizontal and vertical framing members, or the glazing beads aren't fitting tightly, all those things are allowing cold air to get in and around the thermal breaks of those systems. So it may work from an air and water standpoint, controlling it, meaning in and out of the building, or controlling the water collecting in the subsoil and getting out. But those gaps are allowing more air to get in and through the assembly and into places where it can affect interior surfaces of that framing, and we could have energy loss or condensation issues. So just running into the detailing again, one thing that's very common with storefront is you see sill pans shown, metal sill pans, and versus the designed subsill that goes with them. So I thought it would be good, because now we're gonna dive into more of the field detailing. I thought it would be good to start with an historical type opening, a mass wall. Very common with mass wall construction, you've got a nice veneer brick, and then just who knows what's inside the wall. It might be 15, 20 inches thick, but the brick in the center is not continuous. It's not fully mortared shut. So in the old days, you know, as soon as that mortar would break down on the outside, or even if it didn't, we could have water getting into that opening. And we really didn't have high performance air and water barriers or waterproofing like we do today that could collect it and drain it out. It was basically in the opening, and it would show up as a leak or leak through the window system. So sill pans were often used to collect that moisture that came through the wall through cracked brick or just areas where the mortar would break down, or just discontinuous transitions, things like that. We know that the brick is not watertight. So it was just a way we knew that we had to address it by collecting it and trying to get it out rather than it seeping through, getting to the inside further, or just saturating the wall for extended periods of time. So we really heavily relied on flashing to get water out of the building. The problem in new construction is that sill flashing really, it kind of doesn't have a place anymore, because we've got high performance subsills that can collect water in the opening and collect water from the storefront assembly and drain it out to the front. By penetrating that primary seal with the subsill flashing, or sorry, the sill pan flashing, we've got a thermal break. We don't have the ability to seal all the blind fasteners that go through it. Once you're putting the subsill in, you're going to have to drill down through that sill pan anyway. The other big thing is, if you're worried about the window leaking, you have to worry about the sill pan leaking too, because the same installer is likely going to be installing the sill pan with end dams that can leak. And then you got to put a subsill on top that have the same type of end dams that have to be sealed properly. So in my opinion, it's getting less out of the opening will help you put the parts that are in there correctly, because you're not smashed in a 1/4 inch joint with a piece of sheet metal and a sealant joint to try to get this thing air and water tight. Thermal bridge is another part of it. You just got a thermal conductor in through. The other big one is that anytime a sill pan is used, or any type of perimeter flashing that has to go into the opening and be fastened to the opening, it has to be installed before the window goes in. So now we're talking a huge construction sequencing issue. If that perimeter flashing has to go in before the window, generally it's either the cladding manufacturer or the cladding installer has to install that flashing. It's usually part of their scope. So if it requires that flashing to go in first, then the cladding wants to go in first. That means we're delaying the window from going in and delaying the building from being air and water tight until the window's in months after the cladding, months into the project after the cladding's done. And that can delay interior finishes and construction. So it's better, to get that system in as soon as possible before the cladding. These flashings, they look great on details, but sometimes they have a huge impact on the project, especially construction sequencing, but also performance. We think, having that flashing in there, oh, it looks great. It's like a backup if that system leaks, but it's got to be put in perfect. It's going to have blind penetrations through it. We have to make the end dams air and water tight. We got to fit the end dam in the perimeter joint condition so that we can get an actual engineered sealant joint. A lot of times we have such a tight clearance there that trying to put an extra piece of metal in there is really problematic. The other part is it has to be bed fully in sealant. It's a blind seal in that sense too. Otherwise, you've got a perfect pass for air and water underneath that flashing. So there's a lot of reasons why we need to eliminate those flashings that are associated with the cladding, and then also the sill pan flashing, which really, in my opinion, is obsolete at this point with a storefront system with a thermally broken subsill. It adds more problems than it does benefits. So here's just the connection between the two. No, just from our earlier conversation, just that tie-in of the primary to the backup wall, we're offline there. So we're not really connecting them. Sorry. So we talked about it here. So yeah, sorry, I'm getting distracted here, but so the connection of the primary joint to the air water barrier, for all those reasons that we talked about, now we're relying on this flashing that's blind set and sealant and penetrated by blind fasteners to keep water out of the opening. Let's shift that system back. Let's try to get that primary tied into the air water barrier. On the right there is an example of the system where we've got the primary joint in. We've added a second joint. Now it's tight to do this with storefront, but it can be done. Adding that second joint to the outside that really acts as a bulk water joint allows us to do all that cladding and flashing separate. So this system was able to go in when the air and water barrier was finished and we had the building basically air and water tight, and the cladding could come later simultaneously with the interior finishes. So that's the detail on the right there. So here's just another example of that. This architect had a sill flashing in there. We went to do a mock-up test on the right, or sorry, on the left. This mock-up was an enclosed mock-up. Basically it was a walk-in chamber. So we filled it with smoke, pressurized it. The first thing we saw was a bunch of smoke coming in, coming out underneath that flashing, which indicated that we had a discontinuity there. It wasn't bed and sealant. It wasn't tied in properly. We just didn't have that flashing sealed properly. When we went to do the water test, similar issue. Water was getting in underneath the sill. It was coming through a fastener that was through that sill pan flashing that we later found. So on the right, in the blue arrows, just that path that we're seeing, we saw both the air and the water in that mock-up test. So here we took it apart, and this is what I'm talking about. This particular flashing actually wasn't a full sill pan even. It was just a piece of flashing that was stuck into the opening. So we had unsealed edges. When we lifted the flashing up, you could see unsealed that blind penetration. So even when you bed this in sealant, sometimes you might not find that bed of sealant with the fastener that you're nailing down through it with. So you could have basically an unsealed fastener penetration underneath that flashing. And then the lower center picture here, there was no bed sealing at all in this case, which happens a lot. That we can draw it in a detail to put that sealant in, but oftentimes it gets forgotten, or it's not continuous, or they didn't put enough, or they put the flashing in over the sealant and then they moved it, but you can't inspect that. You can't see whether it's continuous after it's done. It's all covered up. So sometimes you can shove paper underneath it, or some type of rigid, sheet of plastic, something that can find its way underneath the flashing to see if that sealant's there. But oftentimes that's really hard to do. So again, it's really difficult to make sure that flashing's been done in a way that keeps air and water out. And by relying on a blind bed seal, it just, it can work, but oftentimes it doesn't work. In this case, we integrated, now this is a window system, but same concept. The primary joint here is at the outer joint. So in this case, what we did, because we didn't have an alternate way to attach that flashing, they needed that aesthetic flashing on the front. In this case, we actually integrated the piece of flashing with another piece of self-adhered membrane, and overlapped it. And then basically all those fasteners that were exposed down that they had sealant on, we actually had membrane lapped over. So if water did get underneath it, we still had a way to block it from getting further in the opening, because that membrane was lapped on the back side of it. It sealed the side edges and the back edges from allowing it to get further into the opening. So we tested it again. Again, we were able to, by doing the interfacing the way we did, it allowed that we set that window back, we integrated the flashing, we tied the perimeter joint into the air water barrier around the perimeter. We were able to test this thing just with the air water barrier on the wall and the window opening. And here's an example of that. So this test was actually done at, I believe, 8 pounds of pressure, which is roughly a 40 to 50 mile an hour windstorm. So wind rain event. So after we got that detailing dialed in, we tested probably 15 windows on this site, and every one of them passed. So we were able to integrate that flashing. It worked. There was sort of a challenge, which I'll bring up next, that we had that flashing integrated. It had to go in first. It sort of was hanging out there. So this is where it comes to construction sequencing, going back to that perimeter flashing, having to put that flashing in and then wanting to get the window in first. That yes, it makes sense from it getting the building air and water tight. But if we have this flashing hanging out that's integrated with the air water barrier, now we've got this flap that's hanging out that can get damaged. So we got this building air and water tight. They were doing interior finishes, but then they had a bunch of openings where guys were on the lifts and they were just hitting that flashing and it damaged it. So now what do we do? So we go back to that construction sequencing thing. Because it had to go in first, they had to take the windows back out to replace the flashing. So it worked from a performance standpoint, but construction sequencing, we got the order that we wanted, but then it didn't work from a damage standpoint because we had to take out all these windows to fix it and put it back in right. So trying to decouple that flashing from the window itself is very beneficial. And there's different tricks to doing that. Up on the top here is an example. Basically, we've got this flashing, we've got blocking. It's just got a lip that sort of clips onto the back of the blocking and slides down. So it almost acts like a cleat. And then that's allowing to be concealed by that outer bulk water joint. The lower detail is a flashing receiver. There are fenestration flashing receivers that are on the market that allow you basically to screw the flashing receiver onto the opening. It allows for that tie into the primary joint around the perimeter. And then when you're ready to come back later, it's got a clip that actually affixes that flashing into the receiver, and then you're done. So it allows for that construction sequencing to happen. It allows for that direct tie into the air water barrier, and everybody's happy. Okay, so here we've talked about this detail before, that pathway for air and water. Sliding that system back. Again, this is just another example of trying to get that, what we would like to get that detail to look like. So the difference between the detail on the left and the detail on the right, now we're not relying on the mason's flashing to keep water out. Now we don't have that open backed storefront frame exposed to that cavity ventilated air or unconditioned air. Essentially, the brick flashing could completely fail and we still wouldn't get water in the building. Now the cladding wouldn't do well over time. It probably would degrade because we weren't evacuating the air or the water properly, but it wouldn't be an issue on the inside of the building. So it's just a redundancy thing. Why? And also a liability thing. Let's separate the trades from each other. Let's not rely on a mason. They're not thinking about water in the opening. They're thinking about their flashing for their system. Let's keep that storefront out of that picture and let's just tie it directly into the air water barrier so that if these other systems break down, we would still have an air and water type building. So just trying to shift that system back a hair just to line up that that framing with the backup wall. If you have blocking, to bring the air water barrier out, they can line it up to that, or use a collar flashing of some sort. There's different ways to do it, but having that tie-in of the primary joint of the storefront to that air water barrier is the critical part. So you just got to try to do that no matter what you do. Now, attaching the flashing at the perimeter, the receiver works. There's also, you can, architects won't like it, but you can use a little angle and use a rivet or a recessed fastener. There's different ways to attach that flashing at the perimeter that can work. Aesthetically, the receiver is probably the better option, but there are different ways to decouple that flashing from having to attach it into the return surfaces of the opening and keeping it, from having to be installed before the storefront goes in or window. Getting close on time. So yeah, just here's another example. Again, this is a window, but this is the idea that we want to have when we go to test the building. Take the cladding right off, and we should still be able to perform from an air and water standpoint. If you push that storefront system out and you do not tie the primary joint into the air water barrier, it will fail at one of these mock-up tests almost immediately because water is going to go right into the framing, drip through all the metal-to-metal joints. It's going to get on top of the glass and drip through the interior gaskets almost immediately. So when you're thinking of interfacing it, think of it as testing the building naked. Basically take the clothes off of or in this case, it would be the cladding of that system and just expose what's actually doing the work from an air and water standpoint. And that'll help guide any interface that you're doing. Especially storefront. and windows. Here's just another example. You know, we were able to tie the system directly into the air water barrier. In this case, we had an accessory perimeter condition or perimeter flashing assembly that allowed us that tie-in. But they were able to get this building. They had the roofing on, air water barrier at the wall, all the glazing in, and the building was air and water tight. And they were running. They had almost all the interior stuff complete as the cladding on the outside. I think the cladding was actually finished after the interior was finished in this building. So just that power of that from a construction schedule standpoint of having the building dried in quicker. The interface details of the enclosure are such a key component of that. Being able to get them dialed in so you can get those critical assemblies in and tied into each other as quick as possible is key. And a detail can work when, you know, there are many different details that can work in a job. Not all the details will work for the life of the building, construction sequencing, and the best performance. So the interface is the key part to that. Dialing in on that on every interface, whether it's the wall to the roof or curtain wall to wall, curtain wall to roof, all of those have a component in them that will impact construction sequencing and performance. So I mentioned additional information. So this is an article, a blog I wrote. It's got some solutions in there for Storefront. Just additional information on the issues or not issues, the challenges with Storefront and some of the background information. So I know this presentation was quick. This will allow you to sit and read some of the concepts and things that I discussed in today's presentation. So check it out. There's some good videos of some of the solutions that are provided in that blog. This is just another reference material I wanted to bring to your attention. This is on interfacing curtain wall systems, or just a general article on curtain wall itself. It talks about interface, but it also just talks about curtain wall in general. It's just a good paper to read if you want to learn about curtain wall. And then I also mentioned the wall to roof interface guideline. I'm hoping that we can publish that. I know we're done with it. We're getting to the end of the year now, but the goal would be to early 2022 to release this out. So it doesn't have every single detail that's out there, but it's got some good examples of details that are very common that can help both contractors, designers out there in the field to figure out the best way to tie them in. Sometimes they can be very tricky. So look for that in the near future, and looking for your feedback, additional details. Just if there's any modification to the details that we came up with, more than happy to take in any of that feedback. So I wanted to leave a little bit of time at the end for questions. I don't know if there is any, but if there is any, I'd answer those now. Do we have any questions, Sarah?
We do not, but I have quite a few.
Okay.
So you make a really good point about, trying to move that window inward.
Yes.
Because I'm actually working on 3 projects right now where I think it was slide 31? Yeah, 30, where the window is slightly outboard and the primary seal is, to the exterior cladding. However, the commissioning agent wants to test this facade, like you said, with no cladding on it.
Right.
But we're coming back saying, that's not going to work because the design is actually using the cladding as the primary seal.
Right.
And so, kind of from a contractor's perspective, is there a reason why that's happening? Perhaps the commissioning side is kind of moving faster than what people are designing.
Is that a building enclosure commissioning agent or MEP? I'm surprised that the enclosure commissioning agent would be in that direction, but
yeah, it's a commissioning agent.
Okay. I think it's just the industry hasn't done a good job at that, at defining it's not as clear with Storefront, and the Storefront manufacturers are starting to provide more information. Conyers one, I know that they've actually tested with a silicone sheet where they show it actually tied out to the exterior face of the system, which is basically saying that's where their primary is. Now, you're not going to find the literature that's out there is not super clear. We just know from experience doing it, and just in the enclosure or the building science world, that where that primary joint, it typically lies in that. I feel like in our world, it's accepted as being on the outer joint as being the primary, just because we know that system can't handle moisture inboard of it or air. But like I said, in air barrier, I could pull up any air barrier manufacturer's detail, and they're only showing the interior tied in. And it's, I don't, I think it just goes back to they probably need to be updated. They probably, there's probably some liability to it. It's not easy to detail that way. There's reasons why they've stayed away from it, for the reasons why, why there's challenges with Storefront, because trying to tie in the air water barrier to the outer primary joint is not an easy detail to show in a standard detail.
Right.
That's, it's just, yeah.
And so Greta kind of branched off and was asked, how can a primary seal to cladding be airtight in a range screen assembly? And Greta, correct me if I'm wrong, but I think that kind of correlates to my question, where these assembly openings, or the primary seal was to an exterior metal piece, but the metal piece, similar to the sill flashing, was supported by the cladding. So, if you're going to throw a lot of wind at it, that's going to move, and it's just like not designed to be that way. So I guess that was a little bit different.
Yeah. So in the scenario, where you would, so there is a way to seal the primary to the cladding, to the air barrier, and to the system all in one shot, but it's not very easy to do, because you have to have your cladding. The tolerances are so tight that unless you're perfect, you got to have you have to have it really dialed in with the trades to do it. But basically that, you've got to slip the cladding in so that an eighth of the joint is being touched by that seal, and the other part of it is being touched by the air barrier. And then the other side of it, of course, is touching the frame. But it's really difficult to do. I've done it on jobs, but the tolerances have to be super tight. So the other way to deal with it is you can modify the storefront assembly by plugging the vertical mullions. And then you can get that accessory pocket filler or jam filler that goes in the back, making sure that that's sealed all the way up. That'll allow you to push another sealant joint, get you to get a primary back further. Okay. So it'll give you a little bit of space to shove that system out and get another caulk joint in there. So I kind of show it on the sill detail here, the upper detail. So that's just the sill condition. The sill's actually easier to do it because that sill is continuous the whole way back. So you can actually get that primary back a little, you can scoot it back a little bit. At the jams, that's where it gets a little bit more challenging, because you just have that 3/4 inch, typically a 3/4 inch return of the frame. And then you have the jam filler that snaps in. So you can, if you're able to seal that condition, or even just have a continuous pocket jam filler, that'll allow you to push another piece of baccarat back and sneak another joint in back there. Okay. Trouble is when you get to the jam, the top of the jam, because that jam's hollow, you've got to plug it or put a cap on it. So once you do that, then you can get your primary around the whole way. So there's little tricks there, but then you're getting into like what does the manufacturer okay with that? They didn't test it that way. You're kind of going off on a limb when you start modifying it, but it does work. I've done that too. So the other option would be to do the flashing receiver, which that would allow you to tie your primary right to the air water barrier. the flashing receiver is there to attach the flashing to, and you're good. So.
Thank you. And then we have another question from Steve. In your experience, how often do modern fenestrations fail air testing? I've had plenty of windows fail water tests, but they almost never seem, or they almost always seem to pass air testing.
That's a great question. If I'm being negative, that's because most of the air tests aren't being done right. It is extremely critical that the tear bag is sealed properly around the perimeter. If you have any type of breach, even the size of a pencil, when you're doing that tear bag during the test, you're doing that pre-test where you're trying to isolate the system out. If you have any air getting around that plastic, it's going through the system. And then now we're thinking we're taking out extraneous leakage, but we're actually measuring leakage through the system. So then when they take the tear bag off, the number doesn't change because we've allowed the extraneous air leakage to get around the tear. So if you're doing an air test in the field, you have to make sure that tear bag, you got to go out and inspect what the testing agency did. If they didn't seal it perfectly around the perimeter, there's more than likely you're going to get extraneous air around the tear bag, and then it's going to cause a false positive. So the challenge is if the glazing contractor got sealant all over the frame, there's no way to it's really hard to tape to that. So sometimes when I've overseen them, and I'm not doing it myself, I've actually used silicone sealant or to seal the tear bag better in certain spots where I went across a sealant joint to make sure I had that tear bag sealed off. That's probably a little bit crazy. I'm probably going over the top, but that to your point, I mean, I would say that a lot of the time it's because it's not being tested properly. So we think that it's passing, but actually the tear bag wasn't done properly. That's my opinion. That's what I see often.
Thank you. See, does anyone else have any questions? So I'll do one more reminder. If you want to receive AIA credits, I just posted in the chat a link to where you can fill your information and you can receive it. I also welcome you to join our Boston Beck LinkedIn page for future updates on upcoming presentations. So thank you, Adam. I really appreciate you presenting, and I definitely learned a lot, and we'll be taking some of this information back to the field with me.
Yes, check out the blog I sent. I think there's a lot of good visuals in there of basically the corner of the unit I filmed around the jam and the sill, and you can see it like a real example of it. So
okay, I will post the blog in our LinkedIn group, and I also saw that there was like an ABBA interface guideline PDF. Do you mind sending that to me and I can share it as well, if that's okay?
Yeah, that actually you can go. That link is to the ABBA website. It's actually on the website. But I can send you the only reason I'm entertaining people going there is because there's more articles on there that people can read. So it'd be good to go there to get other reference material too. So
sounds good. Well, thank you, everyone. Enjoy
Thanks,
the
everyone.
rest of your evening.
Awesome. Thanks, guys. Thanks, Sarah.
Thank you.
Nice. Right. Give me a few moments. I have things I need to bring up, such as meeting agendas. Okay. Do we have everyone here still? Great. All right, so I would first like to start off with elections. And thank you everyone for responding to me about welcoming our newest board member, Ryan. So I want to say hi. Thank you, Ryan. I appreciate your interest and also joining our board. So I think most of you may have met him. He was also at the reception at the WAGMI and Symposium where we kind of reconnected, and I went over the charter with him and kind of brought him on board as far as our responsibilities, responding to emails, and also kind of brainstorming ideas where he can get involved and kind of help us make a difference in our industry. And I received a response from, I believe, everyone welcoming him to the board, at least all of our active board members. So thank you for doing that.
Thank you all very much. Pleasure to be a part of the team.
Welcome. Yeah.
Hey.
And so our next, I guess, big election is for the future chair. And so I kind of started talking to Stephen, I guess, the beginning of the year to see if he was interested. And I'm very glad that he said yes. And since then, I've been kind of copying him and CCing him on emails to kind of get, to give him an idea of the responsibilities and, you know, like what it's like. And so I would like to do a verbal vote for us to, I guess.
I'm sorry, who are you nominating?
Steve Holland.
Oh, Steve Holland.
Hey, everyone.
Great.
So I'm nominating him. I've kind of talked, like I mentioned, with him for the past couple of months, and would like everyone's feedback on, you know, electing him to be our future chair.
I might as well jump in before anything to say that been on board about a year now. Really excited by the work you guys have done, and you know, I've been kind of a bit of an observer in the past, but Sarah's kind of getting me ramped up, and I'm excited to help out however I can. So I'm excited if you give me this opportunity, but you know, happy for any feedback.
Good.
Yep. Sounds good to me.
Yep, I'm voting yes for Steve.
This is Rick Pansera, yes.
Yes. Oh, is this the official vote?
I think so, yes.
Thank you, everyone. I appreciate
All
it.
right. Well, welcome and congrats.
Yay.
So also kind of moving on to a few other things for us to talk about. We do have our we do have our next meeting planned for January, when and he's presenting a case study about three failures and a save. So that kind of gives us time to talk about who we want to ask for February and March. And I sent out the meeting minutes, so I'll open those up.
Hmm.
I'll share my screen. Is this too hard for everyone to read? I have it in blackout.
No, I mean, it's not hard to read.
So we kind of left off either Lori or Matthew to kick off the spring, integrating a high efficiency HVAC unit with the building envelope, followed by balancing client expectations. So I guess I would kind of like your feedback of whether we want to, if I should ask them again to confirm, or if there is another theme that we kind of want to tailor to.
I'm sorry, I think I missed the last meeting, but I don't know who Lori and Matthew are.
Yeah, you have to give the syllabus. You have to put the syllabus up. Syllabi.
Oh, from your summary that you sent out quite a while ago. Yes.
Right.
But it's Lori Ferris from Goody and Clancy. Oh, nice. Yeah.
Yeah.
And Matt Carlton. Right. Well, Matt Carlton, it was a different topic. on lead and enclosure commissioning?
So his topic was balancing your building architect's guide to lead and balancing the client expectations.
So it's not like HVAC balancing, it's
Right.
expectations. It's about building enclosure commissioning. I think Richard Kelleher had really wanted a presentation like this where people think that they're asking for building enclosure commissioning for a lead credit, but it's not the same as, you know, the ASTM standard and other standards.
Right.
And-
Yeah, I think that's really valuable. Let's see. I don't have his summary because I didn't get that far into asking him yet. Or maybe I do. It's somewhere buried in my emails. But I can ask him about it, because what I'm kind of finding and would also like to have someone present on is, you know, when they put all these tests, like commissioning tests in their specifications, but, you know, the client doesn't want to pay for all of them. For instance, like a dynamic fan test, the specs are like, yeah, that sounds great. And then the client finds out it's, you know, $10,000, just arbitrary number out there. And they're like, no, like, we don't want to do that. So it's kind of, I think it's valuable going over setting your client expectations.
Yep. This one,
And then,
yeah. Well,
or we have plenty of time if we want to reach out to someone else. These are just the two presenters that I reached out to in September to gauge their interest, and they were interested.
Yeah.
But they don't they're not really, I mean, they're both related to commissioning, so I guess they're related, but, you know, what is our vision for I guess the spring?
so you're looking for a theme.
Yeah, or if we want to do a theme, that's kind of up to us. Right now, it's shaping up to be about commissioning and HVAC systems, but we haven't really had a talk about what we wanted to do yet.
Trying to think of a theme. But I don't know. I like both of these presentations. I don't think there's a problem with them, especially if you've already reached out to them.
Okay.
Yeah.
I know
So-
Matt's whenever we were planning the symposium, it was between Matt and another person to go on to commissioning. So whenever we read his abstract, it definitely seemed interesting.
Okay, nice.
Yeah.
Okay, so I will reach out to them too and confirm for February and March. So that puts us, I don't know if we want to talk about April and May, or do we want to talk about special events? I don't know if we have a better idea of like COVID restrictions around that time, if we want to start to plan a building tour that we can align with a presenter in the summertime. Does anyone have any ideas about that?
I don't have any ideas, but I support a building tour. I'll dig through my emails because I remember speaking with somebody about touring a project. I just can't remember which one it was.
Okay. Let's see, I think I have notes at the bottom. So we also, these are previous ideas that we talked about, I believe, in the beginning of the summer. You know, planning for renewable and land use, choosing and specifying green products that embodied carbon, which I think is a really good point. So I was in the field and I was talking to Maria at WJE, and she was saying she's working with this client and they want to use all renewable materials. So like no mineral wool and like no foam. And she was talking to them. It's like, well, you know, it kind of gets to a point where, sure, you want to choose products that have a low embodied carbon, but if your building is going to leak, or if it's not going to be, you know, thermally efficient, then are you really building an efficient building? And it's kind of like, where is that line of, oh, like, let's all use like mass timber, and all these, you know, products that are coming out that are low embodied carbon, but, you know, is it worth it to shy away from continuous insulation on the exterior with mineral wool? And is there like a push where perhaps we can put this back on the manufacturers? Because I know mineral wool out in like Canada, they have one of their facilities runs 100% on like hydropower. So I think there is a push from like our clients of, you know, we want to be like low embodied carbon, and they're caring a lot more about where they're getting their materials and how it's manufactured, which isn't necessarily on the designer, but more so the manufacturer. So it'd be interesting to kind of bring that topic to light.
Well,
I think
I
that's,
think, oh, good.
I think that's really important. And I've been seeing that not only coming from clients, but also coming from designers. It's becoming a significant priority. And, you know, for example, Gensler is going to be eliminating from their library anything that does not have an environmental product declaration. So I think that this idea of embodied carbon ties in with the idea of EPDs. And I think EPDs are becoming, you know, much more significant and in demand in the industry. And maybe there's a way to kind of roll that into the same conversation in terms of how they're important, why they're important, and how to actually make them a useful tool and not a encumbrance.
Yeah, I think EPDs, looking at EPDs is much more worthwhile than just a calculation of embodied carbon, because some materials, okay, maybe they use a little more or less fuel to manufacture, say, but maybe they use a lot of water, or maybe the waste of them goes into streams and poisons streams. So I think embodied carbon, and I also think that whole discussion is sort of a little outside the realm of the Building Enclosure Council, unless, like Sarah was describing, it's framed in terms of what are the trade-offs. And I really think the life cycle analysis and the EPDs are a much better tool that really consider the whole life cycle of the thing and what does it do to the environment in multiple ways, and not just some embodied carbon number.
Right.
Absolutely. And I think that the EPD stuff can also tie into this conversation about cradle to grave versus cradle to cradle, and some of the other ways where we can sort of reinvent our thinking, and where some of the manufacturers are, you know, starting to lead things in a better direction, and, you know, how that conversation works with ownership and design and construction.
And I think I've seen a few of these talks now on embodied carbon or EPD, but it's always been holistically about buildings as a whole. But if it could somehow be tailored for the enclosure, where, you know, we're directly trading off the thermal performance of our envelope versus, we thought that improving our envelope was going to help reduce our utilities and be better for the environment. And then now we're kind of coming back the other way, saying that some of those decisions are hurting us. So I feel like if it could be tailored to just enclosure related, that could be a really interesting presentation.
Yeah, I think Maria was saying how, you know, they didn't want to have continuous insulation on the exterior, so they ended up, you know, having this really thick wall and just filling it with that insulation. And she's like, well, I really think you should have like continuous, and they're like, no, like we don't want anything. And she was like, okay. But yeah, to your point, I think, you know, embodied carbon is such a huge buzzword now that maybe someone has a presentation about, okay, why don't we focus on things that are already established, like EPDs, and how you can use them and how they're more efficient than trying to chase this arbitrary embodied carbon number where no one really understands it yet.
And it was actually invented by the oil companies.
Well,
You're
that
welcome.
doesn't surprise me.
It was, but anyway, that's neither here nor there. But I agree with you,
Yeah.
Sarah. That's really chasing that number around. I think there's got to be more meaningful ways to look at it, and life cycle cost is something that I've always looked at. Like performance of products and life cycle costs. It's great to use a green insulation, but if it's our value is like 2,
Right.
and it costs just as much to produce, then what's the sense?
Yeah. The other there's so much about EPDs that people don't quite understand as well. I mean, sometimes your numbers might look great if you're coming from Europe, but then if you're doing your EPDs for the US for transportation reasons, which might sound counterintuitive, it doesn't look so good. So there's all sorts of subtleties there that it would probably help, everyone in the industry to sort of shine the spotlight on some of that stuff.
I agree.
So, should we accept it or not? Should we
need
tool
to
it toward?
We need to find, it's a great topic. I
Topic.
think we tie it to building enclosure performance, but we need to find a speaker or a panel.
Yeah. I don't know if the red list, declare label sort of organization, if there's somebody in that realm that makes sense to tap, or if there's some better resources. But I think I think it makes sense to dig around and try to find some people that can really speak to the significance of the EPDs and whatnot.
Yeah.
What's red list organization?
It's just
The red
it's
list.
one of the ingredient lists that people ask for sometimes, where you basically say, here's all the stuff in here, just like the recipe for a baked good or something, but you have to list everything. They have a list, the red list, of things that you're not supposed to have in there. And then, if you do, then okay, there's certain ways you can manage it, but ideally you find a way to build your product without that stuff.
Okay.
It's just one example.
But I think that doesn't tell the whole story.
No, certainly not.
EPD does.
Exactly.
No.
But I guess it's like a start to where to find someone to talk about this.
Well, I'm just suggesting that just like the embodied carbon discussion, there's this idea of the red list or the ingredients that are involved. These are all just small, tiny pieces of this big idea of the EPD. So, where exactly we find the person who can kind of stitch it all together. I mean, like I said, Gensler is requiring EPDs for all their products now. They probably have some consultant or some resource that has helped, guide them towards making that not very arbitrary decision. So, I work closely with them. I could ask them sort of who's been helping steer that conversation. Maybe there's a resource there that would be of value.
Right.
I'm not sure.
So there's one thing which is good in itself, is just saying you've got to give us an EPD, and we're not going to evaluate it and say this product is this EPD is better than this. We just want your company to take responsibility for doing this kind of evaluation and publishing it, and admitting that yes, we do cause some acidification of streams or whatever one of the things is, but because the second step would be evaluating and saying, well, this product is better than this. But EPD gives you 12 different things that it's looking at, and might be higher in some and lower than in others.
Right. So you can pick and choose what,
So
the impacts really are.
Gensler was clear that once they have EPDs for everyone, they are prioritizing embodied carbon. But I think it's a really good point. Like, assuming that people do get EPDs, how do you then go about evaluating them? And I think that's a very open conversation, and definitely somewhere we can sort of chip in.
I just feel down the road, we're going to be sorry if we only look at embodied carbon. But anyway.
I totally agree,
I
Greta, 100%.
But that's the trend. But it's a good idea, Sarah, also because it might bring some other people, might generate some interest from people who don't always come to BEC meetings if we're addressing something life cycle, EPDs.
Mhm.
Perfect.
Well, maybe we should all try to think of resource people we could come up with, because we have a few months.
Mhm.
Yep, maybe you can, Ryan, if you can reach out to Gensler, maybe over, I know we're kind of going into the holiday season, but just to see if they have a contact that
Yep.
we could reach out to. And like, say if they give you a contact over the next 2 weeks, or even, I guess, the first week of New Year's, then that still gives us, 2 months, I guess, like 1 month to find someone. Well, because we're already booked out till March, so.
Yeah. But if all they're doing is harping on embodied carbon, then they might not be the right one. Because I think
Right.
one of the hopes of this is that we'll get somebody who can talk about EPDs and open up people's minds to all the other important factors. So, but absolutely, I'll pursue that and see what I can find.
I know I personally don't know anyone. I can ask friends if they do, and we
Yeah.
can kind of, I don't know, send a mass email if we have any contacts by like the beginning of January, or like the first 2 weeks in January.
I know a lot of people who have had EPDs done on the manufacturer side, but that's not exactly what we're looking for. But there's a few avenues I can investigate, and if I come up with anything good, I'll let you know.
Okay, great. Thank you, Ryan.
Yep.
So before we kind of get, I think we're pretty good. We have 3 events, and then the 4th one in the works. And for special events, or like special event ideas, we have been kind of not filtering, but bouncing around the idea of like a hands-on like mock-up or a rodeo. And I was also kind of throwing the idea of maybe we have a specific meeting that's not necessarily tailored towards architects, but building owners. And I think what would be unique about that building is that presentation is we would have to spend more time targeting like audience members who normally don't follow our social media. But perhaps we can talk about what to expect during construction, or, whatever you guys think a building owner should know. But I feel like we're kind of missing out on a key sector of the industry.
What if we tried to target just like college and university and higher ed type stuff, because they have official people who would sort of engage in these sort of discussions, and they all build 100-year buildings. It might make more sense than having, people that do colleges, people that do hospitals, and people that do, low-income housing all in the same room. At least they'd kind of all know each other. Maybe they'd have some commonality. I don't know, just a thought.
Yeah.
I probably have contact.
Lined. Yes.
I know probably at least 4 people who work in university, planning and construction departments that I could invite to something like that. And nice thing if we stay virtual or hybrid, one of them's at Princeton University, and another one's at Brown University. They could still, well, one of them, some of us know, is Jonathan Barron. He's now at Princeton University. That'd be kind of neat to get him.
Yeah, I have a few that I can reach out to too. So I do like that as far as like narrowing the demographic of people, and they're working on these very, I guess, expensive long-term, projects. I'm sure a lot of them, it's not their first rodeo. So I don't really know what, I guess, like how preliminary we should get, or perhaps like what the topic is.
Well, maybe if it was just something as simple as, how do you balance the needs of your, institution financially, programmatically, whatever, with this idea that you want your building to last 100 years. And that's where we can kind of like, it makes sense to just focus on that group of people, because not everybody is out there building 100-year buildings. But for the majority, I've done a dozen or so, university projects, and they're all expecting to own, operate, heat, cool, maintain their building for 100 years. So they're trying to do it right, and I think that makes them a good fit for what we're doing.
Perfect. All right, I like it. So maybe we can plan for something like that in, what, do you think summer would be a good time? I don't know if it's like, if they're all going to be like super busy, because that's when all of their projects are going on. But, or also maybe it's like, maybe that's a good time.
Yeah. I'm not sure. The only thing I could think of in terms of why to do it one time or another is there is this conference, I believe it's annual, the Med Ed conference, and it's medical and educational. And I don't know if it's in person this year or not, but it tends to bring together the same type of people that we might be reaching out to.
Okay. That's a good
Not
point.
that we would have to do it at the same time, but just a thought.
Right. If anything, it'd probably be better if we don't do it at the same time.
Yeah, sure. Yeah, fair. But it would be, it'd be a lot of the same people that go to that on behalf of the universities and whatnot.
I like it. So should we kind of put that idea, not necessarily on the back burner, but keep it in mind, and kind of, I guess, brainstorm presentation topics and perhaps like people who may want to present, or maybe the first thing that we do is kind of brainstorm and put together a list of people that we know. I know about 3 or 4 people I can add to the list, can send around like an Excel document and have like their contact information. And then from there we can say, okay, let's pick this topic and let's pick this date, or, find someone. What are your thoughts and the best way about organizing this?
Yeah, I think maybe if we like get together our contacts and then we can send them what we're thinking, I guess. Because I think if I ask around, I have a couple project managers that work with like MIT people, Harvard, so I should be able to get some contacts like that work in the building facilities department that would be interested. So that's just my thought. I think, yeah, if we gather that and then we send them something like,
Do
yeah,
we
or
maybe want to just
then we
have like
think of
at least like a, yeah, maybe just have like at least a little blurb or something, that so that we're engaging everyone with the same sort of, introduction at least, I don't know.
Yeah.
But
So
And then just kind of thinking out loud, do we want to ask them to propose a topic that they think would be beneficial?
I don't see why not.
but
Or we could have some options. I don't know. Yeah, I don't.
Right. I don't know
Yeah.
if it's like too broad.
Right. Yeah.
I mean,
Well,
why
I think
not?
if,
I think what you wrote, building science basics, what architects and building envelope specialists do, would that be a starting point, and then they could respond to that and offer something specific or different.
Yeah.
I don't think we would be presenting the construction process from an owner's perspective. We would want
Yeah.
to contribute that to the discussion. I mean, or maybe we should get one of them to present on that.
Yeah,
Maybe
we
like an
could.
OPM that works well with universities.
sorry.
Or maybe this can be something like it's a panel discussion.
Yeah, because I think everyone's going to have something to add from their own, successes and challenges and their own personal experiences. But I think they'll all sort of have common goals or ambitions, which will make it interesting.
Okay, so it's shaping up to be like, some of the next steps are a blurb to send to our contacts that kind of touch upon what I have here, the basics of envelope science. We're looking to put together this presentation tailored towards, facility managers like yourself, Would you be interested in this event? And if so, are there any specific topics that you would like us to cover or have any ideas for us to mention?
Sounds good.
Okay,
Like
all right, I'm gonna write that down. And then we can probably put that. Does anybody want to volunteer to kind of put that blurb together and then maybe have it ready by the end of January? Or maybe it's something like a great excuse to reach out to our contacts and wish them a happy new year, by the way.
I'd be happy to put something together, and then people can perhaps tailor it to their, specific clients or contacts themselves.
Perfect. Thank you, Steve. All right, so it looks like we are pretty far out, which is great. And another thing that I wanted to talk about was in-person meetings versus virtual meetings. So Susan Green reached out to me, and I don't know if she also sent you all the same information, but pretty much invited us, here I can stop sharing, invited us to use the BSA space.
Yeah.
So I don't know how people feel about that, or, maybe the next meeting is in January, like, should we ask them or like send a poll, or we make the
Maybe.
decision?
Do they have a hybrid option? Because I think that would make a big difference in my vote, is if there could still be people who can travel into Boston, or the parking in Boston is too expensive or whatever.
So here is the email from her. So all of our conference rooms are now outfitted with meeting owls. So those who are not familiar with meeting owls are
Yeah.
integrated with 360.
Yeah, meeting owls, yeah.
Yeah, so we could do a mix then.
Cool.
Okay, so it is
Yeah.
hybrid.
Yeah.
So what she was saying, everyone who does go in person is required to wear a mask. And that she asked at least one person from the organization to be there to kind of greet our guests. So I'm fine with doing a hybrid. I'll be honest, my schedule is very unpredictable because a lot of the time it's based on the weather. So I don't know if I'll be able to do every Monday, but at least most of the Mondays. So I don't know if we want to kind of have like a sign-in sheet where we kind of take turns being the person to welcome, or perhaps if you guys work close to Boston, because I know I don't really often work in the city. If you just always plan on being there because it's like a 5-minute walk from your work. I don't really know what y'all situations are like.
It's possible I could take some of the,
I'd like to go
couple of
to-
the Mondays.
I'd like to go to-
You want to do in person, Luke? Sorry, I can't really hear you. Okay, that's a yes. Okay, so I guess the good question is when do we want to do this?
That's a good question, really good question. It seems like things are going sideways right now. So,
Yeah.
Maybe
Maybe tentatively into
announce it
February.
at the next one that will go move to like a hybrid, or we just move
So
to hybrid.
I have an idea. When I reach out to Lori and Matt, I'll ask them if they're comfortable with doing in person.
Yeah.
And kind of based on their response, we can kind of gauge if we want to bring it in person, because I don't really know if it's worth inviting everyone to show up to the BSA space for all of us to watch a computer screen.
Mhm.
Or, you know, we can bring
Agreed.
popcorn and like make it a movie night.
well,
Yeah.
We get pizza and beer, right?
Right.
yeah. Yeah, I don't know. I think at the very least, it has to be hybrid,
Okay,
or you're gonna lose people.
Yeah.
If it's all in person.
I agree. But I guess the question
People are
is,
not ready to venture out, not even in March or April, we don't know.
Well, what if we just find a presenter who's amenable to one of our next 3 presenters who's,
Yeah.
and then see what it's like
Mhm.
and see whether the interaction flows, even if you're not there in person, and
Yeah.
whether the people who are there. But I guess, like you say, it would be good for the presenter to be there and one of our board members to be there in person if we're going to do it a hybrid.
Yeah.
But we could just say, we're just going to do it in February and see how it goes.
Sure.
Or something like that, rather than say, okay, from now on,
Right.
I don't
Or we
know.
could check out one that's occurring and see how it's going, like, sample it
oh, that's
before
true.
we do our. Yeah, do we know any of there are any committees that are meeting that are gonna be doing hybrid, in the next, well, probably not this month, maybe this month, I don't know.
I
be
don't, but I
interesting to
bet
find out.
Susan would know.
Susan would definitely know. And it'd be interesting, maybe we can, 1 or 2 of us can attend, somebody can log in online and see how it goes, and somebody can show up in person and see
Mhm.
how the experience is.
Mhm.
And if it seems like, because I really don't know. I mean, this technology is still kind of in its infancy. I mean, it certainly is, making big strides, but is it going to be like seamless? Probably not. So
Yeah.
it's interesting to know where the limitations are and see if it's something we think will work with our format. And
Right.
and then we'd have to convince a presenter to, present in person, I guess, right? That would be ideal.
Yeah.
People want to see people in person. So there's a little bit of legwork, I think, I would like to see done.
That all makes sense, Rick. I think getting someone to present in person is kind of critical to even starting the hybrid meeting thing.
Yeah, absolutely. Right.
Yeah.
And I think you'll find some people will do that. I
Mhm.
think that there's a lot of people that want to present in person. They just don't have a platform to present in person anymore. So,
Right.
Yeah.
You could probably just ask and say, hey, would
Yeah.
you present at the BSA in person? And they would say, when can I do that? How soon?
All right.
Yeah, I'm just
Oh,
curious
sorry, go
when
ahead.
you're in person. So will the remote viewers have a screen that's kind of a view of the room, and you see the screen and then you'll see, say, Len Anastasi walking back and forth and pointing to things? Or will it be like a Zoom thing?
It's
I'm just-
more interactive. It has a camera that like either pans the room or encompasses the room, so you actually see what's going on in the room. So you see, it's almost like you're there. But I don't know how well it focuses on whether there's a split screen that you can set up so that you can actually have the presentation, and then see the viewers, see the room, or whether it's just the room. I actually don't know. I mean, there's a couple different ways of doing this. So,
Yeah, I've never used Meeting Owls before.
no, I've not done them either. I've heard about them. Like,
I really like the idea of seeing someone else who's doing this and how it works.
Yeah.
yeah, I don't want to be like the
and I
first
wonder-
person standing in it.
Yeah. Yeah.
And I wonder
So
about
scope out the situation first.
Maybe I can just Google them after our call and find out what's online, like what's available. There's
Just
got to
would-
be a demo in YouTube somewhere.
Yeah. Or we can ask Susan.
Yeah.
So
Yes.
if you want, I can follow up
Yes.
with Susan. I'll see if there's anything local that, I'll copy everyone so you can get her response back and kind of, sign up. Oh, hey, I'll check it out. Or worst comes to worst, we just, YouTube it.
I think Luke had commented just checking out the BSA calendar. That's not a bad place to start. I don't know if they'll tell you how they're doing it.
But
No, they probably are. They probably have some indication now.
if you talk to Susan, she will know, won't
Yeah,
she?
I think I would just call Susan, find out.
Okay. All right.
That would be-
I will
You
reach
can
out
look
to
at the
Susan,
calendar.
Yeah.
and I will also ask the presenters if they want to present in person. and then we'll just take it from there.
Okay. that
What,
sounds like a
when
plan.
we do it, because, you know, perhaps February, they want to present in person, or they don't, and then March does, then we can try in March.
Yeah.
But I don't really want to do January, mostly because I'm not going to be around the first couple weeks in January.
Good for you.
Thanks. I'm going to Utah. I'm going
Nice.
snowboarding with my
Utah.
brother.
Awesome. Awesome.
All right. Okay. Well,
You guys can plan it. I just won't be able to help you very much.
well, why don't we think about February as the, you know, the earliest we would have one of these things if we have one.
Okay.
Like I said, I don't know, you know, like I'm probably more conservative than y'all, but I see that not a lot of people just jumping to like head into town in the dead of winter in the middle of, you know, climbing, you know, cases of COVID so that they can attend a hybrid event.
Yeah, I think
Something
you're
about that is a little bit off. But there, I may be wrong. I may be totally wrong. It may be people just clamoring to go into the BSA space.
Or, you know, maybe it's just like the few people that are like, hey, you going? I'm going. Probably no one else is going to go.
Yeah,
so let's
maybe it's
hang
like
out.
people are just fed up with, like, you know, having to deal with Zoom virtual meetings, that they'll do anything to get into a live meeting.
Do they
I
have
don't know.
popcorn and beer at home? I think is
Yeah.
really what it's going to come down to.
Yes, that's right. Well, last time I went to a BSA event, it was a film, and it was popcorn and wine. It's a very
Fancy.
strange combination for
Oh,
me.
Yeah.
let me check my agenda to see if we have anything else.
Somebody was out of cheese.
That's right.
Actually,
That's right.
back to the life cycle
Well,
question.
apparently the popcorn is a big hit.
All right, so I don't have anything else on the agenda, and I think we have a pretty good plan on the special event, which will be kind of reaching out to facilities managers. Steve said that he can put something together and circulate it and kind of tweak it, provide feedback. I'll reach out to Susan to see if anyone's doing this hybrid thing that perhaps we can sit in on. And then
Or
also,
who's doing it?
and who's doing it, right?
Right.
And then I'll also ask the presenters for February, March if they feel comfortable doing it in person. And then Ryan, he's going to reach out to his contacts to see if there's anyone who can present on EPDs. Am I saying that right?
Yep.
Yeah. I also just
EP.
on LinkedIn, and I'm in contact with someone named Lisa Carey Moore, and she's at the Living Future Institute, and she gave a talk at Payette a couple of years, well, it's before the pandemic, but maybe 3 years ago. And I thought she was a good speaker, and that's why I connected with her on LinkedIn. And is the International Living Future Institute, are they the people who do Living Building Challenge? I'm not sure, but she might know of people if she's not able to do it herself.
Yes.
But I could at least contact her also.
Yeah.
Perfect. Sounds good. And before we kind of wrap up, I want to throw this idea out there. I don't know if it's Beck related, but kind of stemming from what Wei said about kind of engaging the younger generation. I kind of came across this article about this construction company who hosts this event every year, and it's called Build Like a Girl. And whether, you know, we tailor it to just females like they did, or perhaps like grade school, this event pretty much targets kids from 7th grade to 10th grade, and it shows them, there's like a 2-hour panel discussion, and then there's more like of a hands-on, like a 3-hour workshop where they like lay brick or they operate equipment. It's more construction heavy, but perhaps we can kind of turn it into like envelope science. Perhaps, you know, they lay down waterproofing. I don't know. Maybe they're not as excited as I am. And then they finish it up with a building tour. which I thought was really cool. So I don't really know where to start, but I love this idea. And so I'm just trying to figure out if anyone else is interested, or perhaps we can tailor it. There is a lot of coordination involved, so I don't think it's perhaps going to happen this year, but maybe next summer. Also, it would be a summer event because the kids aren't in school.
Right.
But just kind of throwing that out there, if any of you have heard of an event like this, or be even interested in kind of starting a subcommittee.
I think the idea of engaging the youth is interesting. But go ahead, Rick. Sorry.
No, sorry. I was going to say that, let's take a look at it. I mean, I'm not that familiar with it. I've heard that term. I've heard that line, but I don't know what it is. I think it's definitely interesting. And I think we should definitely take a look at it and see how it is that we could adapt something like this, because I agree, educating the young people is really important. And we don't do it well. I mean, we don't even do it well in our office, like it's just, it's right now it's kind of hit or miss. And, even though we think we're doing a really good job, we're not firing on all cylinders.
But you're talking about the recent graduates of architecture school.
I'm talking about anybody, recent graduates or people that have even been working 5 years in the firms. They just are not, there seems to be, in my opinion, a general lack of knowledge and like how to go about doing anything. Like they don't even research, like people just like, they don't do the kinds of things that, we all had to do. Some of us, not we all, but some of us had to do.
Peer-reviewed sources.
One of the big gripes I heard recently from Eric Hollenberg over at Jacobs, he says, he's talking about the younger architects. He says they don't even visit the mock-ups. They don't even go on site and take a look at the mock-ups. And that to him was like a hugely frustrating thing.
Yeah, for some of them,
kinds of learning opportunities,
Right. For some of them, the final product is a rendering. Yeah. I mean, but no, I mean, it's like they just don't take the time to like dig, like they, I play a role in my firm where people come to me when they have technical questions, and I usually teach them how to fish more than like give them the answers. And for a lot of people, like they have, like it's so easy to look up stuff now, like back when I was learning, we had Sweets catalogs, that was it.
Well, I think what you're talking about is very valuable, getting some education. But I thought what Sarah was talking about was grade school or high school students.
Yeah, so it's different.
Group.
My idea was kind of, before they entered, or like the early stages of high school, where they're still kind of deciding like what career path they want to do. Because I did call the planning committee that put together this event, and they said they targeted the younger generation because middle school and high school, they're really trying to like focus in on like, okay, like what are your strengths, what career path you want to do. So they wanted to really influence that, especially for females kind of being into the trade. So I'm not saying that's something we have to do, but or maybe we even bump it up and go into like the college classes. Kind of to Rick's point is teach them how like everything's integrated, or how to fish.
Right.
I don't know.
It could even someday morph into a theme, though, because I think all these topics are really valuable and they're slightly different, right? So how we approach the younger people, how we approach college age people, how we approach new emerging professionals, they're all different but important topics, right? So
I'll jump in there that I'm part of ACE mentoring, which ACE is Architecture, Construction, Engineering. And that partners industry professionals with high school students, usually sophomores to seniors, and sort of gives them a taste of what the disciplines are like, architecture, construction, MEP, engineering, and puts them on like a little sample project to give them a taste of what they might be doing in those fields. And hopefully the idea being they have a chance to try out a whole bunch of things to see if the ACE field is really for them or not. So very similar field, maybe some opportunity for collaboration. Nothing off the top of my head, but maybe something like that.
I love it. I didn't even know that existed.
Yeah, very cool.
Yeah.
Well, if anyone's interested in, we had mentors usually for kind of year-round things, and then we also have opportunities for guest speakers. I've been pushing for an envelope presentation for a while, but I haven't quite gotten them to come around yet. everyone's always interested in the the lead stuff in the passive house. And I try to tell them we can work the envelope in there, but they haven't quite come around yet.
It's the key component, man.
I know. I think we should be one of the 6 disciplines, but so far we're a sub-discipline.
Oh, so sad.
Invent your own discipline.
I have to teach structural engineering when I'm there because there's no envelope sections. I have to lean back in my college years.
Oh God. I can give you my references. I don't really want to look at structural engineering. But all right, yeah. We'll also kind of keep that in our back burner pocket, bring any other opportunities that we kind of come across throughout the year. But I think we got a lot going on and I'm really excited.
Great.
Sarah,
there
I assume you're
anything
done
else
with
that
your
anyone else
references because you
wants-
just passed your PE exam. Congratulations.
Thanks.
Yeah.
All right. Congratulations.
It's such a big relief. Now I have like all this time on my hands and I'm like, what events
Yeah,
can
I
I
know.
coordinate?
Yeah.
Or travel and go to Utah and visit my family. So it's
Do
nice
that
to have
instead. Do that.
freedom.
Check out all the passive houses they have out there in the Mountain West. I
I'm going to
understand that.
Salt Lake City, so I'll check them out. I'll have to do a little Google search.
Yeah, I mean, I have a friend who's a contractor in Salt Lake City, and he's like, "Oh yeah, we have a few of those out here." But I have to think that there are a lot more. I know in Colorado, it really is big because when I was doing my certified passive house consultant thing, like like 80% of the people in the class were like contractors who were building passive houses. Like they were already like doing this, and they were all like in Colorado or like New Mexico or Arizona or California or something like that. So, and I said, well, I don't even know a passive house going on around here. Like I'm sure they are, but like it just was like it was just wasn't aware of it going on as much as out there. But anyway, yeah, do check them out.
All right, we'll do.
If you happen to see any from the slopes.
That's right.
Yeah.
And do get some snowboarding in while you're out there.
Oh, definitely. I got the Epic Pass, so we're going to Park City and Snow Basin.
Nice.
So it'll be a great trip. I'm like meeting like 4 other buddies that are scattered throughout the US, and I just invited them to my brother's house. I was like, your house is great. You're like, these people. Can we just sleep on your couch? He's like, okay. So it'll be fun. But all right, guys, is there anything else that we want to bring up?
Oh,
Thanks
I
again
think
for
we're
having
good.
me.
Yeah,
Yeah.
welcome to the team.
Yeah.
Good to have
See
you
how
on
much
board.
fun we are?
Oh, it's great. No, that's why I'm here.
We were more fun in person, but
All right. We'll get back there eventually.
like I didn't even realize my camera's been off for the whole time. All right, okay.
Oh, I figured that was intentional. I was like, good
No.
service.
I switched computers a couple different times during the presentation, and then like I didn't realize that. It was like, and I'm on my iPad now. It really only like the default is it shows you like who's speaking.
Right.
Okay.
So I haven't been looking up as often as I think. All right. Anyway.
Well, good to
All
see
right.
you, Rick.
All right. Good seeing you too.
yeah.
All right. Okay.
right.
So are we going to
Holidays.
declare victory and adjourn?
Yeah, I think so. And
Okay.
everyone, a happy holidays, and we'll reconvene probably in February, I think, and we'll just kind of communicate via email before then.
Sounds
Awesome.
like a plan.
And Steve, thanks for stepping up on the future chair. Congrats. and-
Yeah, Steve. That's really
Looking
great.
forward to it, guys.
Really, everybody is so happy because they're relieved they don't have to do it again.
No. We're just happy for Steve.
It's a good sign.
He's gonna do great.
All right.
All right.
All right, bye everyone. Have a good night.
Good night.
Thank you, everyone.